Hello and welcome to this animation about the Quantum Slit Experiment and how that connects to us. Our world is made up of particles, the tiniest building blocks of everything. Welcome to the quantum world. Let's start simple. When particles like electrons are fired through a single slit, they behave just as we'd expect. They pass through and hit the screen in a neat single band, like tiny balls travelling in a straight line. Now, what happens when we introduce a second slit? When we add a second slit, something strange happens. Instead of forming two bands, the particles create an interference pattern, behaving like waves, suggesting that they pass through both slits at the same time and interfere with themselves. It's as if the particles don't choose one path but behave like waves, exploring all possibilities. But what happens when we set up a detector to see which slit the particles go through? When we introduce the detector to observe which slit each particle goes through, they stop acting like waves and return to behaving like particles, forming two distinct bands on the screen, just as if they'd only passed through one slit or the other. So, just by taking action and observing the particles, we change how the particles behave. It's as though our observation helps determine their path. This idea of observation influencing reality links to the law of attraction. The law of attraction suggests that our thoughts, focus, and intentions shape the experiences we attract into our lives. Just as in the experiment, reality is filled with possibilities. But when we focus on something, whether positive or negative, we collapse those possibilities into a single outcome. Like the particles in the double slit experiment, our focus and energy influences the reality we experience. By directing our thoughts towards what we truly want, we help shape the world around us. Quantum physics shows us that reality is not fixed, it's full of potential, and perhaps our minds are more powerful in shaping those possibilities than we ever imagined. No one, not even the best quantum physicists in the world, can explain why, by just observing the particles, their behaviour changes.